Welcome to the course on autonomous vehicles. In this lecture, we will discuss about what are autonomous vehicles, their advantages, their classification, autonomous systems, and technologies used in building autonomous cars and systems. So let's get started. With the growth of automobile industry and advancement in technology, humans invented different kinds of vehicles, from earth-moving vehicles to gigantic trailers with more than 100 tires. Each passing decade has brought technology-induced progress in vehicles, from single-cylinder to multi-cylinder, from spark plugs to multi-point fuel injection systems, from manual to automatic transmissions, from key to biometric vehicle access, and from seat belts to pre-collision alerts. Technology has always shaped the auto sector. The aim of such innovations is to make driving more comfortable, easier, and safer. So, the next logical goal was to develop cars that run without drivers. And if you think that the concept of such driverless cars is a recent phenomena, you are mistaken. One of the very first experiments in a self propelled driverless car was carried out in 1925, which unfortunately lost control twice before colliding with another stationary vehicle. But the quest for a truly driverless automobile has been ongoing since that time, and today we have more or less achieved that goal. So, what is an autonomous vehicle? By definition, an autonomous vehicle is a vehicle that can drive itself without any input from a human driver. They are also called self driving cars or driverless cars. Now, thanks to technologies like artificial intelligence and machine learning, these vehicles can automatically sense and adapt to dynamically varying environment. But why opt for autonomous vehicles in the first place? So there are two main reasons for that. In the early last century, when automobiles were just introduced, the fatalities due to vehicle crashes were alarming. Car accidents still continue to be the leading cause of accidental death in countries like India, where automobile density is more. Rather than technology, one of the most primary causes of such accidents is human errors. Since truly driverless cars do not rely on human judgment, they seem to be a logical answer in reducing accidents. Human fatigue is another cause of accidents, especially where long journeys that last more than a day are concerned. An autonomous vehicle would effectively reduce accidents caused by tired drivers. Yet another advantage of driverless cars is that there will be less congestion on the roads as traffic lights will connect with the cars and regulate traffic flow based on real time data. This will also reduce vehicular pollution. Since they are automated, such vehicles will also be capable of traveling more distance at a stretch than a human can. Another point to note is that self driving vehicles will need to not only obey traffic laws but also to adapt to road conditions and implement driving strategies that account for uncertainty about what other road users will do. They are therefore expected to drive cautiously rather than take risks. Take the case where an autonomous vehicle is arriving at a signal where lights are just turning from green to orange before turning red. A human driver might be tempted to accelerate in the hope of beating the red signal. However, a driverless car would most certainly play it safe and stop at the signal. So, to summarize, autonomous vehicles are expected to reduce accidents that occur due to human error and fatigue, ease congestion, and reduce vehicular pollution. Now coming to classification of autonomous vehicles. As the race for driverless cars intensified, there was a need to formalize the definition and levels of automation. So, the Society of Automotive Engineers, which is an internationally recognized professional association for standards development, classified degrees of autonomous vehicles such as level 0, that is no automation, and the driver performs all the driving tasks. Okay, this can be compared with a simple Maruti 800 or Alto vehicle, which are completely manual. Next is level 1, which is driver assistance, where the vehicle is guided by the driver, but some driver assist features may also be included. Next is partial automation. Here the vehicle has combined automated functions like acceleration and steering, but the driver must maintain control of all driving tasks and monitor the environment at all times. Then comes level 3 or conditional automation. Here the vehicle can run autonomously, but the driver must be ready to take control of vehicles at all times with notice. Then we move to level 4, which is high automation. Here the vehicle is capable of performing all driving functions under certain conditions, but the driver has the option to take control of the vehicle. And again, level 5 is full automation, where the vehicle is capable of performing all driving functions under all conditions. But here also the driver will have an option to control the vehicle. These standards have been adopted by the National Highway and Traffic Safety Administration of most countries and also accepted by major stakeholders in the automotive sector. Now, autonomous vehicles as a part of autonomous systems are no longer a distant future goal. Companies like Google, Uber, and Tesla are working on making them happen now. The automobile industry has been assimilating different technologies over the past years, and driverless cars may be the culmination of these technologies. But first things first, what do we exactly mean by an autonomous system? An autonomous system generally refers to a system that can automatically sense and adapt to dynamically varying environment. Apart from artificial intelligence and machine learning, autonomous systems use a broad spectrum of technologies to make a driverless car really work. Okay, though it's not possible to cover all the technologies, but we will discuss about the most common technologies here. But before we dig into what these technologies are, it is very important to understand why driverless cars need all these technologies at all. Human beings are amazing creatures. There are other species that may excel in speed, agility, stamina, and physical tasks, but no other species can perform complex real time calculations of their physical environment and generate specific actionable predictions like the humans. So, driving a car takes an incredible amount of real time data processing, assessing various driving and environmental conditions that change rapidly, and taking intelligent decisions based on this information. So, a trained human driver realizes when to change the gears, when to press the brake, when to accelerate, and when to slow down. And the more they drive, the more driving comes naturally to them. Changing gears, accelerating, deaccelerating, braking, changing lanes, gauging through traffic conditions, and driving accordingly becomes their second nature. If someone honks or an ambulance turns on their sirens, they know just what to do. So if a driver is familiar with a road, he or she knows exactly where the blind spots are, where the speed breakers are, and so on. So they prepare for it. Of the five senses they possess, humans use sight, sound, and even touch while driving a vehicle. They know exactly how to drive in foggy conditions, windy conditions, or how to react if someone suddenly crosses their path. To perform equally well, autonomous vehicles need to incorporate different technologies to satisfy their human qualities. So now let's talk about these technologies. First is artificial intelligence. While many definitions of AI exist, one of the most informal and simple definition is to getting computers do things that would normally require human intelligence. A few important aspects of intelligence, including the ability to sense, reason, infer. AI involves processing massive amounts of structured and unstructured data called the big data. The ability to reason and to draw inferences based on context driven situations and the capability to analyze and solve complex problems in various domains. In driverless cars, AI allows for flexible and error free driving through the aid of AI assisted softwares that enable the autonomous vehicle to navigate even the most complex traffic situations. Machine learning and deep learning are subsets of AI ecosystem, and they are also ways to create or train AI. Machine learning is an application of AI that enables systems to learn and improve from experience, while deep learning is a subset of machine learning and leverages complex neural networks to extract more detailed features as the neural network continues to learn and evaluate its input data. Autonomous vehicles rely on advanced artificial intelligence and machine learning systems to understand their environment and react to commands. Next, coming to sensors. If AI and machine learning are the brains of autonomous vehicles, sensors are the nervous system that feed the data. Sensors are fundamental to the perception of vehicle surroundings in an automated driving system, and the use and performance of multiple integrated sensors can directly determine the safety and feasibility of automated driving vehicles. Sensors used in autonomous vehicles can be classified as active or passive. Active sensors have a signal transmission and emit energy in the form of electromagnetic waves. That is to say, they actively send signals in order to receive a feedback. While passive sensors detect existing energy like light or radiation reflecting from the objects in the environment. Sonar, radar, LiDAR are examples of active sensors, while radiometers and infrared cameras are examples of passive sensors. The main types of electronic sensing devices used in driverless cars include cameras, radars, and LiDARs. Autonomous cars often have video cameras that see and interpret the objects in the road, just like human drivers do with their eyes. Radars send out radio signals that detect objects and gauge their distance and speed in relation to the autonomous vehicle in real time. An important advantage of radars is that they also can determine the relative speed of the detected obstacle, which is very important for decision making in acceleration as well as for braking. LiDARs do the same as radar. However, They use lasers instead of radio waves to determine the distance and type of object. The choice of sensors used in autonomous vehicles is dependent on many factors, including their range and their price. Any moving vehicle needs to be able to avoid close objects at the same time sensing objects from far away from it. The sensors mounted on the autonomous vehicles also need to be able to operate in different environmental and road conditions with challenging light and weather conditions. Next, coming to geolocalization and mapping. Like human drivers, autonomous vehicles need to answer questions like where am I, what objects are around me, and how do I go from here to my destination. Geolocalization and mapping help provide this answer. The default geolocalization method is satellite navigation, which provides a general reference frame for where the vehicle is located on the planet. In addition, autonomous vehicles also need to know how to proceed from location A to location B, and maps are needed for this. HD maps are one of the best ways ahead as they have many more details than traditional maps. These details include information like road location, number of lanes, current speed limit, traffic signs, parking spots, traffic rules at intersections, severity of any curves that may be present on the road, and many other details. HD maps are usually made in layers and it takes special software and hardware to come up with a suitable HD map that autonomous vehicles can rely on. While no one has doubts that autonomous vehicles are just around the corner, no one can yet predict when it will find mass acceptance. Although technologies like artificial intelligence, machine learning, autonomous systems, LiDAR, radar are important drivers of AVs, safety is the key word that will make them successful. With the recent malfunctioning of autonomous vehicles from the world's leading companies, common people are still circumspect about them and not without a reason. They are serious reminders that research and development on autonomy, safety, and assurance are still not adequate or experimental or production level autonomous vehicles. One of the most tangible benefits of autonomous vehicles is supposed to be the safety they offer. However, as autonomous vehicles integrate nascent technologies like AI, ML, and the adoption of more distributed and networked architectural platforms, the design, the modeling, verification, and validation of today's autonomous and intelligent systems have become increasingly challenging. Evaluating the safety aspect of autonomous vehicles is a daunting task as it is the most critical part of an autonomous vehicle's success. Conventional design and validation methodologies are often not sufficiently equipped to address the challenges of an autonomous vehicle's safety. In order to create a truly safe autonomous vehicle experience, it is crucial to validate its performance over all possible environmental scenarios. However, such an evaluation is a very difficult task as there are almost innumerable variables that vehicles face on the road. Two such technologies that can be of use are augmented reality and virtual reality. AR and VR are already popular in other sectors like aerospace and manufacturing industry, but they look destined to play a critical role in the safety of autonomous vehicles as well. AR is an alternate reality technology that provides an enhanced version of the real world by overlaying our existing reality with an additional layer of digital information. While VR is a technology which allows a user to interact with computer simulated environment using sensors. Both AR and VR find uses in industry, education, and entertainment, and companies that provide AR VR services are in demand in India and the rest of the world. Augmented and virtual reality have in fact already been accepted by the automobile industry. AR head up display or HUD is a driver assistance that provides basic real time information such as vehicle speed, warning signs, and navigation that is protected onto the inside of the car's windshield so that the driver can stay focused on driving. Virtual reality showrooms allow potential buyers to customize any make or model in exactly the way they want. VR training tools have been developed that upgrades the skills of automobile technicians. AR and VR are now making inroads in autonomous vehicles as well and will play a vital role in ensuring their safety. Augmented reality's ability to seamlessly integrate a virtual environment into the real world makes it the ideal candidate for the testing of driverless cars. AR therefore provides not only a safer approach to testing but also a more economical one. LiDAR, one of the technologies used in autonomous vehicles, ensures a precise depth mapping almost immediately, irrespective of the settings. Augmented reality can provide more accurate depth perception and virtual object placing to this LiDAR, improving safety. The second way AR is useful is improving the safety of autonomous vehicles to people. Let us face it, people are concerned with the safety of the autonomous cars, especially after crashes reported by major companies who are at the forefront of developing AVs. Even though AI, ML, and numerous sensors should prove to be much safer than human drivers, people will be much less forgiving of machine errors over human errors. Companies are experimenting with providing AR experience to people where real vehicles can interact with computer generated cars in real time. Researchers use different real world scenarios that enable them to access the safety of driverless cars. Researchers are also working on using AR simulation to test software that enables real and virtual cars to communicate with each other. If that happens, it would enable the autonomous vehicles to make better driving decisions. Thus, they can navigate any environment safely without endangering the lives of their passengers. Yet, other companies are using AR maps to show people how driverless cars navigate the real world, allowing them to understand how driverless cars will function. In autonomous vehicles, virtual reality can be used to generate realistic virtual scenarios to train MI exhaustively. This can eliminate the need of manual annotation because VR systems can generate the scenes and annotation metadata about the scene's content automatically. VR is recognized as an excellent alternative in studies or simulations to avoid the risks of physical setups where people can be injured. VR has been used for training for a long time now as it can simulate situations that could be dangerous or life threatening in the real world. VR can hence provide training possibilities that otherwise would be costly, risky, or even impossible in the physical world. Virtual reality can be used to train and test interactions between humans and autonomous vehicles in a realistic environment and without the physical risks of the real environments. Using virtual reality, it is possible to augment the AI and ML algorithms used by the autonomous vehicle software in order to improve its safety significantly. In addition, virtual reality can also be used to train users to regain the car control and react properly in dangerous situations without risking their lives. So, this was all about this lecture. See you in the next one.